Welcome to Brain Vision.
Okay, so we know the flow work can be equal to HL minus UL, which is UT minus UL. HL here is the enthalpy of staying in the supply line. UL here is the internal energy of the staying in the supply line. And UT here is the internal energy of the staying stored in the tank. As you can tell, UT is equal to HL. The reason why the internal energy of the steam stored in the tank is equal to the enthalpy of the steam in the supply line is because flow work of the steam in the supply line is transferred to sensible energy in the tank. Okay, and well, first let's try to determine the internal energy of the steam stored in the tank. So we know at 4 megapascal, 550 degrees Celsius. If you take a look at the table A6, which is the table for the superheated water, 550 degrees Celsius is lying between 500 degrees Celsius and 600 degrees Celsius. So at 4 megapascal, 500 degrees Celsius, we have the corresponding internal energy is 3100.3 kilojoule per kilogram. And at 4 megapascal, 600 degrees Celsius, the corresponding internal energy is 3279.4 kilojoule per kilogram. So therefore, we can use the interpolation to determine the internal energy of the steam stored in the tank, which is UT here, eventually is equal to 3189.9 kilojoule per kilogram. So now we know UT is equal to HL, so therefore the HL, which is the enthalpy of the steam in the supply line, is also equal to 3189.9 kilojoule per kilogram. So now we use the same table, which is A6. So we know at 4 megapascal, if you take a look at the 4 megapascal section, the enthalpy 3189.9 kilojoule per kilogram is lying between 3093.3 kilojoule per kilogram and 3214.5 kilojoule per kilogram. So therefore, well, we know if you take a look at the table, so at 4 megapascal, 3093.3 kilojoule per kilogram, the corresponding temperature is 350 degrees Celsius. And at 4 megapascal, 3214.5 kilojoule per kilogram, the corresponding temperature is 400 degrees Celsius. So now we can use the interpolation to determine the temperature of the supply line. Okay. So therefore, we have temperature of the steam in the supply line is eventually equal to 390 degrees Celsius. So now we know the temperature of the supply line. So therefore, we can determine the internal energy of the steam in the supply line. So we know if we use so we still use the same tables with the same section. So at 4 megapascal, we know the temperature 390 degrees Celsius is lying between 350 degrees Celsius and 400 degrees Celsius. So we know at 4 megapascal and 350 degrees Celsius, the corresponding internal energy is 2827.4 kilojoule per kilogram. And then at 4 megapascal, 400 degrees Celsius, the corresponding temperature is 2920.8 kilojoule per kilogram. So therefore, we can use the interpolation equation to determine the internal energy of the steam in the supply line. So eventually, we have the internal energy of the steam in the supply line is equal to 2902.1 kilojoule per kilogram. So now we can determine the flow work. So the flow work is equal to UT minus UL, which is equal to 3189.9 kilojoule per kilogram minus 2902.1 kilojoule per kilogram, which is equal to 288 kilojoule per kilogram. And this is the answer for this question.